special interaction with Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India. This interaction is brought to you by the Office of the Principal Scientific Advisor to the Government of India, marking World Quantum Day.
You ask anyone, do you understand gravity? It does not need any high-end science, whether the apple falls on the ground, which Newton observed, or whether you observe anything falling. Quantum effects are seen when you are dealing with microscopic objects like atoms, electrons. Even in 1982, I will come back, Feynman had predicted what quantum computers could be doing. Actually, I'll first give you a very simple example. Imagine, where is the security? So that all the countries have a issue where they want to be quantum safe. What does it use? It uses data to train. Quantum AI is the future. Financial sectors are the biggest user of quantum computers. That the Indian financial sector, one of the very important platform for quantum sensing is unveil centers in Diamond.
So in that sense, how can these quantum logistics especially be important for India?
We have to reduce our dependencies on import. We have to. There is no choice. Quantum computing, when it uses a dilution refrigerator, that is what we need to replace, because quantum computing still have many options available.
Marking the World Quantum Day, Office of PSA is releasing the International Technology Engagement Strategy for Quantum. Hello and welcome to a special interaction with Professor Ajay Kumar Sood, Principal Scientific Advisor to the Government of India. This interaction is brought to you by the Office of the Principal Scientific Advisor to the Government of India, marking World Quantum Day, which is celebrated on April 14th every year to raise global awareness about the transformative potential of quantum science and technology. During this interaction, we will also unveil a special edition for India in the quantum landscape, the launch of the first edition of India's International Technology Engagement Strategy for Quantum. This strategy is designed to complement the ambitions of the National Quantum Mission and unify efforts across India's growing quantum ecosystem. What this report unveils, what this entails, and what this strategy is about, why is it important, is something Professor Sood will help us understand during the course of this conversation. The release could not be more timely, as the United Nations has declared 2025 as the International Year of Quantum Science and Technology. And as we know, the world is waking up to the critical role quantum will play in shaping global innovation, security, and leadership. This conversation will not just explore that report, but also give you the basics of quantum, its real-world applications, assess its disruptive potential, and zoom out to understand global trends shaping the quantum landscape. So without further ado, we'll start the conversation and dive into the world of quantum. Thank you so much, Professor, for taking the time for this conversation. So before we get deeper into how the quantum landscape is looking like, I would like to set the foundation, and I would request you to help us understand some core concepts of quantum.
Thank you, Ayushi, for this very interesting podcast which we are going to have on a theme which is very contemporary and also very technologically challenging. Now, if you ask anyone, do you understand gravity? It does not need any high-end science, because we see the effect of gravity in our daily life. Whether the apple falls on the ground, which Newton observed, or whether you observe anything falling, you know there is gravity. But if you ask somebody, do you feel quantum effects in daily life, it is a bit hard, because quantum effects are seen when you are dealing with microscopic objects like atoms, electrons, and so on. But the effect of quantum mechanics have been invoked right from 1913, which is called the first age of quantum mechanics, or the first revolution, where when people saw the gas discharge, to understand that, we had to understand how we do that in terms of quantum mechanics. Of course, the very famous wave particle duality, whether something can be wave and particle in different contexts. For example, electron, is it a wave or a particle? Answer is both. We have famous Schrodinger equation. Then so many things, our daily life which we live with, like transistors, integrated circuits, lasers, whatever you call in our daily life, could not have been possible but for quantum mechanics. That is what happened in the beginning, and we say that we used quantum mechanics to understand the nature. Then the second revolution is what we are talking now in the last 5 years. Second revolution is where we are dealing how to control the quantum systems. So this is a very nice way where quantum technology is engineering the exploitation of quantum mechanics. So it took almost 100 years or even about that time where people realized what needs to be done. Now even in 1982, I will come back, Feynman had predicted what quantum computers could be doing. But before I do that, I thought it might be worthwhile to remove all the fear of what this quantum mechanics is. Sometimes it's called spooky physics. There are three principles of quantum mechanics, actually two to begin with. One called superposition, other called entanglement. Now it's very easy to understand in terms of classical bits, which will explain the qubit also. Our entire life, yours, mine and the entire universe now is on digital technology. Digital technology is working on classical bits, which means either a state can be 0, let us say off state, or can be 1, which is on state. So it can be 0 or 1. That is what you call classical bits, and you know the whole Boolean algebra, everything is due to these bits. When you have a superposition, it means system can be simultaneously in 0 and 1. It's a big shift, which is what happened in 1913. Now you can have simultaneously 0 state as well as 1 state. How much of 0, how much is 1 is also governed by some weight factors. Second property, which is absolutely critical in this quantum technology, is the entanglement, which means if two states are entangled, in my hand if you see, it means if you know about one state, you know everything about other state because they are entangled. So if there are two photons entangled, one photon can be with you, other photon can be on the moon, but you will know what is happening to that photon if you look at this photon. This is the entanglement. In simple words, I am oversimplifying just to convey the point. So these are the two properties which are used. Now what is the advantage in qubit? So qubit is 0 and 1 simultaneously. Now if you have 2 qubit, you will have 4 possible states simultaneously, 0 0, 0 1, 1 0, 1 1. If you have 3 qubits, you will already have 8 states simultaneously, all combinations. And you can see if you have 4 states, it is 16. It is mind boggling. If you have 50 qubits and they are entangled, 2 raised to power 50, just if people work out, it's a huge number. So what it means is that you can have all these states present simultaneously. That is the power of quantum computers. So I have explained you the basics of quantum. Because of superposition and entanglement, we can have all these states present. But the beauty of quantum mechanics is that when you want to measure something, then the measurement affects the qubit. And that comes very handy, which I'll explain in quantum communication. It's called no cloning theorem, which means that moment you try to interrogate a qubit, you lose its entanglement. So if there is a mischief where they are trying to eavesdrop, this will get destroyed. So immediately you will know there is a thief in the present. So no cloning theorem is a very fundamental theorem of quantum mechanics, which helps you in quantum communication.
Okay, this was a very simplified
so this
quick
is like
quantum 101.
5 minutes presentation on a difficult subject like quantum mechanics. But I hope you got the idea.
Yes. So you also mentioned quantum computing, and that is something that keeps coming again and again these days and has become fairly common. Why do we need quantum computing?
Actually, I'll first give you a very simple example where it is a national strategy.
Okay.
Now, all your communication, all your security is based on encryption.
Right.
All your bank transactions, all your messages on mobile are encrypted. What it means that you have a classical message, but you also send a key which is classical. Now that classical key, there are various versions, 128, AES and so on. That is based on some mathematically hard problem. There is nothing mysterious about it. It will give you a very large number, and before you can factorize, lifetime of the universe will be over, because it's such a tough problem, which means 21 you can factor into 7 into 3.
Okay.
That is a small number, but if it is a large number, it takes a very long time. Now this is where quantum computers have shown, because of the algorithm, Shor algorithm, that you can factorize a number very, very easily. If I'll give you one scary example, which will, I don't think it is happening today, but it can happen in few years. If you have 48-bit RSA security, it will take more than life of universe in a classical computer to break. So everyone is happy. But if you get 4000 qubit machine with 100 million qubit gates, and it can break it in just 10 seconds. Imagine, where is the security? So that all the countries have a issue where they want to be quantum safe. It is not a dream or in future, it's happening now. Why? Because your adversaries can store the information now and harvest it when such powerful computers become available, quantum computers become available. So it's a reality, it's not a fear or anything. So in addition to that, there are other beautiful examples which is called quantum supremacy. What does it mean? That problems which are very hard to solve in classical computers by using classical, you can solve them. You will say, what is that example? Give me one. I'll give you one example which is you and I live every day. You know photosynthesis? Mother Nature, how they use the green leaf, convert sunlight, and this thing gives you energy. It is the most efficient process nature has made. Conversion efficiency is close to 100%. So human beings want to know what is the physics, what is the chemistry, what is the biology, because if you can learn that, can you mimic that in the lab? Then you will have all energy problems solved, all your food problems solved. That's what I call quantum supremacy, not me, but what people call. Also, in any optimization problem, like traveling salesman, I don't know if you heard about it. If a salesman has to go to various cities, it is a very important problem. How do you put the routing? Which city he should go so that he doesn't spend too much energy in repeating things. this is a real life problem in airlines. How do they make the routing of their aeroplanes? So quantum computers can do it very, very easily. So already there are companies now in this field who use quantum computers to do this optimization problem. Molecular simulations and discovery in material science and biology, as I said, and the biggest problem which is staring at our face is cyber security. So AI, cyber security and quantum, they will be a big partners. Cyber security will be helped tremendously. And the biggest fun these days is artificial intelligence, right? You talk to anyone even on the street, they may not have the natural intelligence, but they may know about artificial intelligence, right? Artificial intelligence, what does it use? It uses data to train. Then you infer. Quantum computers, for the property I told you, even 50 qubit machines can do all these states so parallelly. So quantum AI is the future. What is the advantage, you will ask? Now quantum, the classical computers which are used to train 600 billion parameter which you have heard, they use classical computers which use almost like few gigawatt of electrical power. So you can see the environmental consequences, the climate change. So AI using classical computers is not a sustainable option. So sooner than later, quantum and AI will marry each other happily, and that's what would happen. Yeah, we are almost closer to that.
We touched upon quantum computers, we spoke about quantum supremacy. You also talked about quantum communications earlier. So could you elaborate that for our audience
so I'll
as
say
well?
very briefly, any message which you send, which you want to be safe, there are two things. One, the message, and the key. Key is the one which will decrypt the message when it reaches the other end. Now, the problem is in that people can break the classical key if they have sufficient computing power. The quantum thing is that in a quantum communication, the message is classical channel, because that is a huge message. But the encryption which you have done with the key is the quantum. So there are two channels, classical channel and a quantum channel. And that is why it is called quantum key distribution. So there are protocols, how do you do it, and this is where a lot of work has been done. Already we have now examples where up to few thousand kilometers quantum key distribution has been done on ground. And I'll tell you more what are the next steps. So this is something what is happening.
Since we're talking about what's happening in the quantum world, where is India in all of this? And if you can discuss on the initiatives, some of the initiatives that the Indian government has taken to support quantum technologies, and where is India on this whole quantum landscape?
I'll just tell you the latest effort, because the efforts have been going on for the last few years, but in brevity I'll tell you so that we don't take too much time. The point is that realizing the importance of quantum technology, this was discussed in Prime Minister's Science, Technology and Innovation Advisory Council, which is one of the key arms of our office, and it was decided few years back that India should go for quantum technologies in a mission mode, which means concerted efforts where we take R&D to technology and market deployment. So this mission was approved about a year back, which is now being run, which is being implemented very, very efficiently by Department of Science and Technology. So there this quantum mission has been rolled out, and there are 4 verticals in that: quantum computing, which I mentioned, quantum communication, which I mentioned, quantum sensing, which I did not mention, but I'll say a word or two, And the fourth one is quantum devices, which will be needed for other 3 verticals.
These are the verticals under the National
Quantum Mission.
Okay.
And in that, in addition to Department of Science and Technology, we have other departments also who are partners. Department of Space is a partner, Department of Atomic Energy is a partner, and MIT and DOT are involved in this mission. So this mission looks at the complete life cycle of a technology. What is the R&D needed? What does it take to translate a R&D to technology, and how do you make a product? So in this, it is a hub and spoke model. What it means is it's not a single PI centric one. So what the mission is that in each vertical we will have a hub which will be institute with many investigators, and there are technical groups which will be associated with a hub. So we will have 4 hubs and we will have many spokes.
Yeah, so I think 4 thematic hubs, the T hubs we have established.
Yeah. For example, Quantum Computing Hub is in Indian Institute of Science, Quantum Communication is IIT Madras and CDOT, Quantum Sensing is IIT Bombay, and Quantum Devices is IIT Delhi. Good news is that there are 14 technical groups which involve 152 researchers, 152, very large number, from 43 institutes, large number, and this is spread across 17 states and 2 union territories. So it's a whole of India approach which we are taking, and it has very unique features which are very nice. I thought I'll take a minute.
Yes, sir. If you could highlight some of the unique features of National Quantum Mission.
It's an example which we should follow in other missions. First, it has very focused deliverables. Second, it is structurally designed to be manifestly collaborative, not individuals only. Third, it will give operational flexibility to researchers through the hub and spoke models. They will collaborate, cooperate. A fourth one, startups will be involved in this, and it will be collaborative thing between R&D labs, academia, industry, research institute, startups. So, and also it is moving towards international collaboration in gap areas. And the last one, and not the least but the very important one, it will develop the human resource for it, for future. So already the programs for MTech have been now formed, and from July onwards many engineering colleges will launch a minor in quantum technology. So as we speak, the subjects, the courses are being formed.
So, sir, those are some very interesting features about the National Quantum Mission, especially now that you said the courses are also coming up. You also talked about startups and entrepreneurship. Startups is something that's we talk about a lot. So if you could help us understand what's the role of startups in National Quantum Mission, and where is India in being quantum ready, and what is happening to create that quantum ecosystem, and how can we move towards having that ecosystem?
Very important point which you have raised. So right from the beginning of the mission, we are very clear that startups have to be involved. Okay. And you know, we have a mission governing board, yes. And then we have the executive council. So what has been happening, what has happened in the last few months, 8 startups have been given funding, okay, which are quantum startups on quantum technology already. Dedicatedly. But now many more startups can be funded by involving hubs also. So it's a very, very important part of the mission to encourage the startups. Not only encourage, but make sure that what R&D is done comes to startups, and also it makes a product. What we have to do next is also create a market for these products. We have to create the appropriate mechanisms that these technologies are deployed. So that is the goal which we will have in coming months.
And sir, since we are talking about taking the research to the startups, the industry products and then market, it also requires funding then. So not just in India but globally as well. How is that scenario when it comes to funding? And there's a lot of patenting also which comes in a field like this because there's so much research going around.
I think this is an area where no country wants to be left behind. Okay. For the reason I told you, it is important for strategic autonomy. Right. You cannot have strategic autonomy of a country if you are not quantum safe, period. So if you look at the funding in the whole world, it's already in the last year, it was close to 35 billion US dollars, 35 billion. And this is increasing with time. And there are private players, governments, a lot of it is government funding actually. Okay. So, both funding, government and private are coming into it. And in a very short span of time, almost like $35 billion are committed. So you can see that this is a technology. Of course, it is a very high-end technology. You need to be very technologically, mature, or you have to know all aspects of this technology. And this is what is happening. There is another thing which will be which is happening parallelly, is all the quantum algorithms are also being developed in addition to the hardware. So quantum algorithms will also play a very important role, and I am very sure India can play a very significant role.
And we did touch upon Indian startups, where you mentioned that recently 8 startups have been specifically selected and they're working dedicatedly. Globally, how is the scenario? Globally as well, there are startups working dedicatedly.
Yes, and there are startups. The numbers I may not know completely, but US has about almost 350 startups in quantum domain. Europe has, and we also have more than 8. 8 we have funded, but there are more than that. And these startups, many of them are in quantum computing.
Yeah, what are the kind of domains there?
Quantum computing is occupying a lot of, because it needs also resources. Quantum communication is happening. I must say that in quantum communication, India is doing quite well. And this is where I think we have a possibility of a leadership. Quantum sensing again is, there are few startups, but it will still need some more time to really see where quantum sensors will be deployed, which are a must, where classical sensors cannot work. So like in examples I can give you when we are at it, like you want to know whether there is a tunnel under this floor. How will you know without digging it? How? Either you have to be a magician or some high-end spiritual person, or what will you do? Now what you do is, you realize that gravity, the way things attract to earth, depend on the mass of earth. So if there is a tunnel here, that attraction will be little less. But you and I cannot sense it because it's an extraordinarily small effect. So quantum sensors have been developed already to detect that small change in gravitational attraction. Now that has an enormous strategic importance. Supposing you have a submarine going, you can detect. You have a tunnel, you have mines, or in ore exploration, mining. So this is where the quantum sensors will come in a big way. It is really the strategic sector which is equally important.
So sir, since we are talking about sectors, globally there are 3 key sectors that have been identified which have been early adopters of quantum science and technology, and these are finance, biomedical and logistics. And this is due to their reliance on high complexity computations, optimization challenges and security demands, which makes them quite ideal to utilize quantum. So if you could help us look at some of these quantum applications
Absolutely.
in the financial sector.
I think it's a very important question you have put. I told you that our financial sector is completely dependent on the security of the data. Because if it is not secure, you and I cannot even do any UPI, correct? Now financial sectors are the biggest user of quantum computers. Now how will they do it? There are 2 ways. Of course the communication can be through using quantum key distribution, but the other one which has taken a very, very good place is called post quantum cryptography, which means you make your algorithms right now even though you are using classical computers, but they are quantum safe. Even quantum computers cannot break the code. So it's called post quantum cryptography. So in that actually it's already happening. And this is what we will need to do in India, how we really do PQC as an integral part of our security things. So things are already happening. We have now a very strong group formed under the mission to look at this quantum safe aspects. You will be surprised to know that HSBC has partnered with some universities in UK like University of Edinburgh, and it became the first bank to join the UK commercial quantum secure metro network. We have Bank of America having patents in communication and so on. So financial sector is completely seized of the matter. We need to make sure that the Indian financial sector comes equal preparedness immediately on the quantum safe communication. So that's a immediate need, and communication, as I already told you, quantum communication is a must. Good news is, which I probably should not forget, the satellite based quantum communication is an extraordinarily important thing, because if you are doing by fibers, it may do, let's say 250 kilometer, then you have to put a repeater safe node because the signal will decrease and all that. Quantum repeaters hopefully will come in coming years, but with satellite where you have 2 stations even 2000 kilometers away, and a quantum and a satellite specifically for quantum application, which India is now developing and it will be launched, that communication can be up to 2000 kilometers. You do not need fibers. So that's what will happen, and that is the future. When I say future, it is next few years, it is not a long time.
Okay. And the next question would have been about India in the quantum state when it comes to financial sector. So we'll move on to biomedical. And if you could help us understand, when it comes to the biomedical sector, what are some of the use cases that we have of quantum technology and some global examples where quantum is being adopted?
Immediately the first thing will be that if you can do this quantum simulations, molecular dynamics, molecular simulations, where you can find out all the pathways, how a drug molecule interacts with protein. That's what you need for drug discovery. So the drug discovery will be very, very fast, and it will not be ad hoc. It will be based on design principles, which is happening now. I am not saying that, but classical computers take a very, very long time. Already you do protein folding simulations using quantum processors. Another thing, imaging. When you have this imaging, can you have very sensitive quantum sensors? For example, in MRI, can you make very sensitive magnetic sensors? Not only that, if you which are already happening in magnetometers, you can really do the brain scan. You can measure very tiny magnetic fields, and you can really detect if there is anything wrong with you. So that is already happening on an experimental scale. So this is where, because quantum sensor is what? It means it can measure extraordinarily small fields, be it electric field, magnetic field, electromagnetic field. It can sensor very small fields. So brain sensors, brain scanners, that will be a reality sooner than later.
And how is India's biomedical research aligned with all of these trends? As I said,
in our quantum mission, it's already happening. One of the very important platform for quantum sensing is NV centers in diamond. These are nitrogen vacancy centers in diamond. So we already have groups which are working in IIT Bombay and other parts of our country. Other quantum sensors based on other technologies are being developed. Gravimeters are being developed, which I said to measure very small gravitational change. It's already happening as we speak. So many of these things are in the R&D stage, and in few countries some of them, some products have also come out, and it's in the early stage. And we are in the same stream to make sure that India also is a player.
And the third sector which has been identified is the logistics industry. Yeah. Now there, if you can help the audience understand how does quantum play an important role?
So as I mentioned in the earlier, in optimization, route optimization, or whether it is real-time tracking, techniques like quantum annealing, people, I won't explain these things because it will take me away. All these are to find the most efficient delivery paths. That's the basic principle. This is what you need to do, as I said, the traveling salesman problem, or any other in machine parts assembly. How many, what should be done, people are using it. So already it is being used to optimize traffic flow in few countries, quantum computers. So which they call D-Wave. D-Wave is the quantum annealer. I will not explain that, but already being used. Similarly, IBM and ExxonMobil, they collaborated to model maritime inventory routing through quantum devices. So good news is that the proof of concept already exists now, and it is not a question of should we be doing it. It is a question how to do it on scale. That's the idea.
So in that way, sir, if I'm getting this right, the adoption of quantum enabled optimization can also support cost reduction and boost trade competitiveness in some manners.
You are on the dot.
So in that sense, how can these quantum logistics especially be important for India, and how can we work towards achieving that?
I can see that logistic cost in India are typically 13 to 14% of GDP, which is a pretty large number. In other countries it could be 10% and so on. Now these high costs you need to reduce because they impact our economic growth. So as you know that we have a very wonderful program started by our Honorable Prime Minister. It's called PM Gati Shakti National Master Plan. Now my dream is, can we use quantum enabled optimization to play a key role in PM Gati Shakti National Master Plan? That's my wish, and in this mission we should do it. Because Gati Shakti mission master plan is absolutely wonderful. It has been rolled out, you know, enormous amount of ministries are involved. It's an optimization problem. Can we use quantum computers? Answer is yes, and that's what we should be doing.
Okay. Now, as we are moving towards the end of our conversation, we've touched upon a lot of things. I would like to talk about some of the gaps and potential focus areas for further development of India's quantum ecosystem. And we've touched upon funding, investment. So some of the other primarily driven things that you think India should be looking at.
See, India has to invest in the hardware also. Quantum hardware is a little bit less than the other things. We have to reduce our dependencies on import. We have to. There is no choice. Quantum computing, when it uses a dilution refrigerator, that is what we need to replace. If we are using some other, because quantum computing still have many options available and we are working on many of them, whether it is using the superconducting qubits, neutral ion, neutral atoms, ion qubits, photonic qubits, spin qubits, many of them are on the table, and we need to develop strategies to do hardware on that. Second, we need to bring much more funds for startups. We need to bring VC funds. We need to bring all models, corporate funding, and we need to make sure that we de-risk the investments, which means we need to create market for the products. And how do we do that? So this is where all the players, be it government, be it private sector, be it academia, startups, all of us play a role to create this ecosystem where the market is also created.
And when we talk of ecosystem, quantum is a subject which is global. It's not limited to any one country. So standardization again becomes crucial in this.
Absolutely.
And international bodies like ITU, ISO, etc. are working actively towards establishing some global quantum standards. So can you talk about that and India's participation there?
There is no question that we need to be an active player in defining the quantum standards, which we are not now. This is the gap we need to fill, because once we have that, we will also play a role in standardization efforts. We will also play a role, and that is what leads to strategic autonomy, because the standards, if they are not where we are players, it can curb us. That's what we need to do. So India need to be a player so that the future global frameworks have our stamp in them. So very proactively we have to do, and very proactively we have to see that we have these global standards, because our market is not only Indian market. We have to be making sure that our market is global, and this is what we need to see. So standards is a very important thing.
And in that sense, since you said it's a little gap, do you think India is well represented in these forums, conferences, or we need to strengthen that also more?
It's happening, but it has to be enhanced much more. So I will not say that it is optimal. We need to really encourage it, and our hope is that quantum mission will enable that. And by the way, all that is built into the mission. So there is already funding for all that. So there is no doubt that it will happen.
And sir, in that sense, I think Office of PSA is also striding towards bridging those gaps pretty much. And I think the International Technology Engagement Strategy that we have, the ITS, is an initiative of the office which is designed to strengthen and elevate India's technology diplomacy efforts across critical and emerging domains, and quantum is one of those domains. And we are happy to announce that in this regard, marking the World Quantum Day, Office of PSA is releasing the International Technology Engagement Strategy for Quantum report, which we have with us. And I would request, sir, to please present and officially launch the report.
I am delighted to release this report. This is the International Technology Engagement Strategy. This is the first edition where we are attempting that this report, foundational report, it offers a very comprehensive analysis of global and Indian quantum ecosystems. It highlights investments, talent, institutions, research and industry activity without prescribing specific policies. It includes detailed insights into our national quantum mission, which we spoke today,
yes,
and which will enable international stakeholders to identify potential collaborators. So the goal is the ITES initiative. Now it is the ITES-Q, which is the first one.
Quantum, yeah.
It supports India's technology diplomacy by providing a structured, strategic framework for international engagement in line with national interests and long-term autonomy,
right,
which will foster meaningful partnerships across governments, academia and industry. I am sure this is a great moment for all of us. Congratulate people on this quantum day, and India is well poised to be a very significant player,
right,
in this whole ecosystem.
Right. Well, that was a lot of learning on this World Quantum Day about Quantum 101 that we had with you, also the quantum landscape in India and across the globe. And as we know through this conversation as well, that quantum is not a distant frontier now. It's happening. We are working on it. And we have identified the gaps. There's a lot of potential work is going on, and bringing together the funding, the research, the academia, the industry, we can all come together and have those quantum dreams see through and be quantum ready and quantum safe. Thank you so much, sir, for taking us through all of this. And thank you to the audience for watching this.
Thank you.
Thank you so much, sir.
Thank you.